Have you ever wondered what truly defines human intelligence? Is it the power to think, to dream, or to create something that defies time itself? Since the dawn of civilization, humans have built, shaped, and invented, from the simplest tools to the most complex machines. But some inventions stand out, not because they were useful, but because they were unbelievably strange. They changed history, yet often remained hidden in its shadows. From ancient mechanical robots to devices that seemed centuries ahead of their time, each invention tells a story of curiosity, ambition, and sometimes pure madness. In this journey, we will explore 50 of the most extraordinary and bizarre inventions ever conceived. Some saved lives, some changed the world, and some should probably never have existed at all. Let's begin with one of history's first mechanical marvels, a creation that blurred the line between man and machine, the medieval robot man. During the 15th century in Europe, engineers created extraordinary devices to impress royal courts and demonstrate their mechanical intelligence. One of the most remarkable inventions of this era was the medieval robot man. Constructed from a combination of metal and wood, this mechanical human could move its arms and turn its head, and some models could even perform simple tasks. It was used in royal palaces to amaze guests and showcase the prestige of the rulers. Some robots could carry food or drinks, performing basic services. The gears and hinges used in these robots were a testament to the engineering knowledge of the time. Beyond entertainment, these mechanical creations sparked humanity's curiosity about measuring and controlling time, because devices with moving parts required precise coordination and planning. This curiosity about time and control eventually inspired the creation of the next invention, the ancient Greek water clock. The measurement of time was critical for both daily life and official matters in ancient societies. In ancient Greece, water clocks were developed to track time using the controlled flow of water. Water would slowly move from one container to another, and markings inside the vessels indicated the passage of time. They were used to limit speeches in court, organize city affairs, or regulate religious rituals. Advanced models even included small figurines or bell mechanisms that moved with the water, combining functionality with visual appeal. Water clocks exemplified early mechanical intelligence and helped engineers refine their skills. The need to monitor time also highlighted the importance of movement and strategy, ultimately leading to inventions like war chariots, which required speed and maneuverability. Through these devices, timekeeping and mechanical ingenuity became intertwined with military tactics and everyday life. Throughout history, warfare has driven technological innovation. In ancient Egypt and Rome, war chariots gave armies mobility and tactical advantage. These lightweight, armored vehicles were pulled by horses, allowing archers or spearmen to maneuver across the battlefield and strike effectively. Pharaohs even depicted chariots in tomb art to display both power and technological sophistication. In Rome, chariots were also used in military drills and gladiator arenas. Some designs featured spiked wheels to defend against enemy attacks. These vehicles were not just transportation. They were a fusion of mechanical intelligence and strategy. The engineering knowledge gained from war chariots later influenced the development of ancient Roman concrete, which allowed for durable and lasting constructions, showing how military and civil engineering advanced together. The reason many Roman structures still stand today is the durability of Roman concrete. This special mixture combined volcanic ash, lime, and small stones. When exposed to water, the concrete would chemically react, gradually hardening and creating structures that lasted centuries. Examples like ports, bridges, and amphitheaters demonstrate its strength and resilience. Modern scientists have discovered that Roman concrete becomes even stronger when in contact with seawater. Beyond durability, This material reflected the ingenuity and planning skills of Roman engineers. The knowledge and techniques from concrete construction also supported the use of mechanical devices in warfare, like bow and arrow mechanisms, which became more precise and effective. The combination of construction and weapon engineering showed the interconnected nature of human ingenuity in that era. In the medieval period, mechanical bows and crossbows enhanced the power and range of armies. These devices were stronger than traditional bows, and some mechanisms allowed a single person to draw a large bow. They played a critical role in sieges, enabling defenders to strike enemies from afar or breach fortifications strategically. Some designs could shoot multiple arrows in sequence, surprising opponents. Mechanical gears and tension systems optimized force and accuracy. Bow and arrow machines weren't just weapons. They were demonstrations of applied engineering intelligence. The mechanical skills required here inspired devices to control water, ultimately leading to inventions like the Archimedes Screw, a mechanism to transport water for agriculture and urban life. The Archimedes Screw was designed to move water from the Nile River to irrigate fields or supply cities. Its helical tube lifted water from one container to another efficiently, powered by human effort. This simple yet ingenious machine increased agricultural productivity and ensured urban water supply. It remains in use in some parts of the world today. The invention of the Archimedes Screw, combining mechanics and practical problem-solving, sparked curiosity about underwater exploration and long-distance travel. This curiosity led to Renaissance diving suits, which enabled humans to work and explore beneath the water's surface. During the Renaissance, the first diving suits were developed to allow prolonged underwater activity. Made from linen and reinforced with lead, these suits protected divers from water pressure and provided stability underwater. The helmet was equipped with air tubes, and weights at the feet prevented floating. These suits enabled exploration, salvage operations, and scientific observation beneath the waves. Human curiosity and engineering ingenuity merged, paving the way for the next groundbreaking invention, the Gutenberg printing press, which revolutionized the spread of knowledge on land. In the 1450s, Johannes Gutenberg invented the printing press using movable metal type. This breakthrough drastically increased the speed of book production, making information more accessible to the public. Before Gutenberg, books were laboriously copied by hand and were expensive. His first printed work, the Bible, set off a cultural and educational revolution across Europe. The printing press allowed scientific discoveries and artistic ideas to spread widely, preparing the ground for innovations like the telescope, which would expand humanity's understanding of the universe. In 1608, Dutch lensmakers created the first telescope, revolutionizing astronomy. Galileo refined it to observe the moon's craters, Jupiter's moons, and the Milky Way in unprecedented detail. Telescopes not only advanced science, but also improved navigation, allowing sailors to spot distant islands and hazards. Early telescopes were simple, yet they sparked a curiosity that drove humans to explore the cosmos. This curiosity, combined with the need for navigation, made the magnetic compass essential for safe, long-distance sea voyages. The magnetic compass, first used in China, fundamentally changed navigation. It allowed sailors to determine direction even when landmarks were not visible. When introduced to Europe, it enabled explorers like Christopher Columbus to discover the Americas. Early compasses also assisted in calculating wind and currents, crucial for long oceanic voyages. The compass combined human ingenuity, mechanical precision, and the spirit of exploration. These first 10 inventions, linked together through mechanical innovation and curiosity, form a chain demonstrating human creativity, engineering skill, and the drive to understand and control the world. The next inventions continue this journey through the Renaissance and Industrial Revolution.